Alright, for this video, this is going to go over day 2 of 2.1, working with quadratic equations. The first video basically worked with completing the square. That was probably the hardest process. The whole point of completing the square was to get the vertex of the parabola. You can see right here, I'm just going to work, this is the definition of the parabola, the ax squared plus bx plus c. What I'm going to do in here is I'm just going to leave the numbers out and just put the letters a, b, and c, which would eventually represent numbers, and I'm going to complete the square with it. And when I derive it, and this gets a little messy, you're not going to have to do this on any test or quiz, but it's still good to know this process. We're going to get a formula that'll easily give us the vertex of any parabola, and we're going to use that with word problems. Alright, if I wanted to complete this square right here, what I would do first is, the leading coefficient's not 1, it's a, so I'm going to pull an a out on the outside. So then on the inside, I'm going to have x squared. Now that bx, I leave that inside. Now since I'm pulling an a out, I'm going to have b over a on the inside. Okay, and then I'm just going to put plus c on the outside. Now it makes sense if you distributed this, a times, if I did this right up here, a times b over a, the a's would cancel and you still have b. So you're still going to have bx. Then I'm going to complete the square. So I'm going to keep the a on the outside. I'm going to have x squared plus b over ax. Then I'm going to have plus, minus, right, that same number, and then plus c on the outside. Now to complete the square, remember the middle coefficient, that's the most important term. So since that's the most important term, remember it's 2 steps. You take half of it. So if I take half of b over a, when you multiply, it gives you b over 2a. That's going to be real important, because we're eventually going to use that when we factor it into a perfect square binomial. Now this, once you take half of it, then remember you square it. Now if you square that, you get b squared over 4a squared. And this actually isn't going to factor into anything that you need to know, but I'm just going to put this in, so it's b squared over 4a squared. So this is where it gets ugly here. And I put the same thing, minus b squared over 4a squared. Alright, now if I group the first 3 terms together, I'm going to have x squared plus b over ax, and then plus b squared over 4a squared. And then when you distribute this a to this, it's going to cancel out with one of these a's here, so it's just going to be minus 4a. So on the outside, we're going to have, let's see here, minus b squared over 4a plus c. Again, that's really not going to be a big part. Here's the main concept. This is a perfect square. So I'm going to factor this into a perfect square binomial, and it's going to be x plus. Now to get this term, I know it's going to be squared. This is always going to be half of the middle term. Well, remember, when we took half of b over a, this is what we got, this b over 2a. That's the key. So it's b over 2a squared, and then I'm just going to drop this down, minus b squared over 4a plus c. Here's the main thing, this b over 2a. Looking at this, according to what values a, b, and c are, the vertex for the x value is going to be negative b over 2a. Right, because since it's plus b over 2a, you take the opposite, so it's negative b over 2a. Then this right here, don't memorize that. That's just too long, and it's really pointless. Once you find out the x value, just doing negative b over 2a, then you just take that x value and plug it in. So we'll just say this is the function of negative b over 2a. Now, out of all of that, that's a big mess that you did right there. The main point, and I'll highlight this, the main point is this right here. If there's anything you get out of what I just did, it's that for any quadratic equation, to get the x value for the vertex, you just take negative b divided by 2a, and that always gives you the x value. So you can skip to that and skip this whole mess that I did with the completing the square. We're going to use this for the next problems. You can see you have ugly decimals, and that's where we're going to use it. So let's look at the first one. Okay, first word problem. Alright. Okay, this first word problem, this is basically flight or path of a baseball. So if baseball hit at 3 feet above the ground, This really doesn't matter to us, this 100 feet per second at an angle of 45 degrees with respect to the ground. Path of the baseball is given by this function. All right, here's the main part. The leading coefficient's negative. That makes sense because a leading coefficient negative is this. This is what the parabola looks like. Well, that looks like the flight of a ball. So this is going to be our vertex. That's how high it goes. Okay, f of x is the height of the baseball, and x is the horizontal distance from home plate. What is the maximum height reached? So this is what we want to find. We want to find this, the maximum height. Now, if I put this on an xy coordinate plane, the ball's hit 3 feet above. So I would say this is 3. This is where the ball's hit, and this is what it looks. It looks something like this. This is what we want to find. Now, saying what is the maximum height? So this is what we want to find. We want to find the y value there. Well, in order to find the y value, I have to find the x value first for this vertex. Well, how do I do that? Again, it's all right here, this negative b over 2a. So if I take negative b over 2a, well, negative b is just 1, and then it's over 2 times, and then a is this negative 0.0032. This is where you rely on your calculator. Put this in your calculator. When you put that in your calculator, you wind up getting 156.25 feet. Now, what does this represent? This was negative b over 2a. This was the x value. So that's the x value of the vertex. That's not what I want. This is what we got. So it's saying at the maximum height, it traveled 156.25 feet. In order to find the y value, I'm going to take this 156.25 and plug into x for the quadratic equation. So to do that, let's just kind of erase some stuff here, give us some space. Okay, this is all we're doing. I'm going to find out basically the function of 156.25. So I'll say y equals negative 0.0032 times 156.25, and then square that, and then plus 156.25, and then plus 3. You can throw that right in your calculator, rely on your calculator. This is why we don't use completing the square, because it gets way too ugly with these decimals. There's no way I expect you to do that, you know, just by doing it by hand. And then when you put this in, your calculator will spit back at you 81.125 feet, and that's the answer. That's the highest point of the arc that the baseball is. That's the maximum height. That's your answer to this problem. Okay, let's do the last one. Let's do number 2. And that's a classic example. We just did number 1. You'll do that a lot in physics. Alright, let's do the last one, number 2. Number 2, manufacturer of a lighting fixture has daily production cost. Okay, C is the total cost in dollars, and X is the number of units produced. How many fixtures should be produced each day to yield a minimum cost? So what we're actually finding here, it just says how many fixtures. That actually is just X that we're going to find. To yield the minimum cost, well, cost is C. That basically is your Y value. We really don't have to find it. We just have to find the X value. So all you have to do here is negative B over 2A. Now here's the other thing. They try to trick you. They switch around the A, B, and the C. Right, the A is always the coefficient for X squared. So A is this, the 0.25. B is the coefficient for the X, so that's this, the negative 10. And A or C is always the constant. So in this case, it's the 800 right there. So let's just list that first so we don't get tricked. A is 0.25. B is negative 10. And C is positive 800. Now, since A is positive, well, think of it. Your parabola goes up like this. So since the parabola goes up, this is where it makes sense. This is why we deal with the minimum cost, because that's the minimum Y value it can go. So makes sense right there. So this is what we want to find. We want to find, basically, you have an X and a Y value. Here they use C to replace the Y. But the question is just saying how many fixtures should be produced each day to yield a minimum cost. It doesn't ask you to find the minimum cost. So I don't even have to find Y. This is all I have to find. Well, I just rely, the only thing I have to remember is negative B over 2A. That's the main point of this video, is negative B over 2A. So if I put in negative B over 2A, I have negative, then I have negative B, which is negative 10, over 2a, so it's 2 times 0.25. Okay, when you do that, you're going to get the negatives cancel out. You're going to get 10 over, 0.5. And 1/2 will go into 10 20 times. So there it is. That's your answer to this question. That's it. That's all you have to do. There's 20 fixtures or 20 units produced. When they produce 20 units, it gives you the lowest cost possible. And that's it. That's your answer. So when doing these problems, you're going to have to do negative b over 2a, but make sure you know, all right, do I have to find the x value for the vertex, or do I have to find the y value of the vertex? If it said, hey, what is the minimum cost, and this is all you do. You just find the function of 20. You just take 20, plug it into all the x values, so you're going to have 800 minus 10 times 20 plus 0.25 times 20 squared. Just throw that in your calculator, and it'll give you an answer. In fact, it'll give you an answer of $700. This would be the minimum cost. Again, I just did that just to clarify what you have to find, the x or the y value. Technically, this is all you had to do for this problem, but just be aware. Do they want you to find the x value for the vertex, or do they want you to find the y value for the vertex? And as I keep saying over and over again, here's the main point that you get out of this. Negative b over 2a. That whole mess where we complete the square, this is the main thing. This is the x value for any vertex of any parabola.